మీ ఉద్యోగ సాధనలో మీకు తోడుగా
మీ S&S పబ్లికేషన్స్.
పబ్లికేషన్స్ వారి పుస్తకాలను ఇప్పుడు మీరు ఆన్లైన్లో కూడా ఆర్డర్ చేయొచ్చు. యూ కెన్ జస్ట్ లాగ్ ఆన్ టు www.sonlinebooks.com. ఈ వెబ్సైట్లోకి మీరు లాగిన్ అయ్యి మీకు కావాల్సిన పుస్తకాన్ని ఆన్లైన్ ఆర్డర్ చేయొచ్చు అండ్ మీ డోర్ స్టెప్ దగ్గరికి డెలివరీ కూడా చేయడం జరుగుతుంది.
Hi everyone, welcome to S Publications. First let me introduce myself. My name is Rao Nageshwar Rao. I am chemistry expert, particularly for all competitive examinations. So in this video I am going to explain TGT syllabus, trained graduate teachers. So this is very important topic. Today topic, chemical bonding topic. This topic comes under physical science. Physical science consists two parts. One is physics and the second one is chemistry. So now I am going to take chemistry part, that is chemical bond. So before getting to chemical bonding, I would like to say one important point. Chemical bonding, it is not a part of chemistry, it is heart of chemistry. That much important topic. So listen very properly. Yeah. So the topic is chemical bonding. So what is chemical bonding? What chemical bonding explains? So chemical bonding explains stability of molecules. So first, each and everyone, you need to understand one important point. Why do atoms are combined? Why atoms are combined? Atoms are combining for stability purpose only. So first here you need to understand one important point. Atoms and molecules, out of two, which is more stable? Always molecule is more stable. Always molecule is more stable. So how atoms are involving in bond formation? We are going to discuss very clearly. Yeah. So what is chemical bonding? So the force of attraction between two atoms or two ions or two molecules is called chemical bonding. So what is chemical bonding? The force of attraction between two atoms in a molecule is called chemical bonding. So what chemical bond explains? Chemical bond explains stability of the molecule. Yeah. So before that, we need to discuss valency electrons. So what are valency electrons? That is very much important concept. Why? Because valency electrons plays very important role in chemical bonding topic. What are valency electrons? What valency electrons explains? So valency electrons plays very important role in chemistry, particularly chemical bonding topic. So what are valency electrons? The number of electrons present in outermost energy level. The number of electrons present in outermost energy level. So the number of electrons present in outermost energy level. outermost energy level. Outermost energy level. Dear students, energy level, it is also called shell. It is also called orbit. It is also called period. So different terminology, but meaning is same. So we can say like this, the number of electrons present in outermost shell. Otherwise we can say like this, the number of electrons present in outermost orbit, the number of electrons present in outermost period. So don't get confused. So terminology is different, but meaning is same. Yeah, let's take one example, my dear students. I am going to take lithium. So lithium atomic number is 3. What is the atomic number of lithium? 3. So atomic number equal to number of electrons. So here lithium atomic number 3, that indication total lithium contain how many electrons? Total lithium contain 3 electrons. But here question is valency electrons. Why? Because valency electrons are active electrons. Only valency electrons are participating in bond formation. Yeah. So total 3 electrons. Here 3 electrons not that much important. Only valency electrons important. So let's write electronic configuration 1s2 2s1. So this is the electronic configuration. This is the first energy level and this is the second energy level. So first and second, out of two, which is the last one? Outermost is nothing but valency. Valency is nothing but ending. Ending is nothing but last one. Yeah. So here last one contain how many electrons? Last one contain only 1 electron. That indication lithium contain how many valency electrons? Lithium contain only 1 valency electron. This is very much important. So here you need to understand one important point. So here total lithium contain 3 electrons, but out of 3 electrons, how many electrons are active electrons? Only 1 electron is active electron. Only active electrons are participating in bond formation. This is a very much important point. So for better understanding purpose, I am going with one more example. For better understanding purpose, I am going with one more example. Before that, so this is the diagram. This is the atom diagram. So atom is made up of protons, neutrons and electrons, and this is nucleus. Nucleus built up of protons and neutrons. Nucleus is built up of protons and neutrons. So nucleus is built up of protons and neutrons where the electrons are circulated around the nucleus. These are electrons. These are electrons. So electron having negative charge, that's the reason I am representing like this, E minus. Don't get confused. E minus is nothing but electron only. So dear students, just look at the board. So this is first energy level, this is second energy level, this is third energy level, this is fourth energy level. So in this diagram, what is the last energy level? In this diagram, this is the last energy level. This is the last energy level. Last energy level is nothing but valency electron. This electron is nothing but valency electron. Yeah. So one more example for better understanding purpose. I am going with beryllium. So beryllium atomic number is 4. What is the atomic number? 4. So already I told you atomic number equal to number of electrons. If atomic number is 6, total number of electrons also 6. If atomic number is 20, total number of electrons also 20. Don't get confused. So this formula is applicable to neutral species. Neutral species means no positive and no negative charge. So let's take beryllium. Beryllium atomic number is 4. That indication total beryllium contain 4 electrons. But here you need to understand one important point. Out of 4 electrons, how many valency electrons? So how many valency electrons, my dear students? Only 2 valency electrons. Why? Because this is first energy level, this is second energy level. So second energy level is the valency energy level. So that's the reason. So how many valency electrons here? Here valency electrons 2 only. Only 2. Next, let's take one more example. I am going with fluorine. Fluorine atomic number 9. So atomic number 9 means total 9 electrons. Total how many electrons? 9 electrons. 1s2, 2s2, 2p5. So these are the electrons. 2 plus 2, 4. 4 plus 5, 9. Is it clear? Yeah. So here, this is the first energy level. This is the second energy level. This is also second energy level. That's the reason you need to consider this part. This part. So total how many valency electrons? 2 plus 5, 7. So total how many valency electrons, my dear students? Total 7. So here total fluorine contain 9 electrons. Try to understand. Here total fluorine contain 9 electrons. Out of 9 electrons, how many active electrons? So active electrons, total 7. Is it clear, my dear students? Yeah. This is the periodic table. This is the periodic table. So you need to understand one important point. So periodic table contain total how many periods? Total how many periods? 7 periods. This is first one, this is second one, this is third one, this is fourth one, this is fifth one, this is sixth one, this is seventh one. Don't get confused. These are F block elements. F block elements are including in D block only. F block elements are including in D block only. These are not separated. Yeah. So total how many periods? Total how many periods, dear students? Total 7 periods. Total how many groups? This is also very much important point. Total groups are 18. Total periods are 7, groups are 18. So period is represented like this, horizontal line. What is the representation? Horizontal line. Horizontal line means like this, like this, like this. So next, group. Group is represented like this, vertical column. What is the representation? Vertical column. Vertical column means like this, like this, like this, like this, like this. Yeah. So here total how many groups? Total 18 groups are there. But here one important point, listen very properly and keep it in your mind. So valency electrons act as group number. This is a wonderful point. Valency electrons act as group number. If valency electron is 1, then group number also 1. So here first A, that indication valency electron 1. Here second A, that indication valency electrons 2. Here third A, that indication valency electrons 3. Here eighth A, that indication valency electrons are 8. So helium is exception, don't get confused. Helium is 1s2, that indication actually helium belongs to S block. For stability purpose, we just kept here. Don't get confused, that is the exception case. Next, neon. You have to take neon. Neon contain 8 valency electrons. If you have any doubt, just look at the board. So neon atomic number 10. Atomic number 10 means total 10 electrons. First, you need to write the electronic configuration. So 1s2, 2s2, 2p6. This is the electronic configuration. This is the first energy level, this is second energy level, this is also second energy level. So here only 2 energy levels out of 2, which is the last energy level. This is the last energy level. Total how many valency electrons, dear students? 2 plus 6, 8. Yeah. So that's the reason this is represented at 8th A group. Generally S block and P block represented by A series, and D block and F block represented by B series. Don't get confused. Yeah. So here 8th A indication, 8 valency electrons. So here what is the formula, my dear students? This is the formula. This is the wonderful formula. Valency electrons equal to group number. Is it clear? Valency theory of electrovalency, that is also called Cousel-Lewis theory. Actually, the total chemical bonding topic depends upon this theory. So what is this theory? What are the main important points of this theory? Don't get confused, my dear students. This theory explains one important point, that is, according to this theory, only valency electrons are participating in bond formation. That is the main important point. So according to Cousel-Lewis theory, only valency electrons are participating in bond formation, and this theory explains octet configuration. So what is octet configuration? We will discuss very clearly. Yeah. So already we discussed valency electrons. What this theory explains? This theory explains valency electrons. Already we have discussed what are valency electrons. What are valency electrons? The number of electrons present in outermost energy level. Number of electrons present in outermost energy level. Outermost energy level. Outermost is nothing but ending energy level, EL. So next we need to discuss octet configuration. Actually, what is octet configuration? Yeah. Just look at the board. So before that, Lewis dot structures. Valency electrons act as Lewis dot symbols. Valency electrons act as Lewis dot symbols. Lewis dot symbol. Yeah. Let's take one example. Lithium, atomic number 3. First you need to write electronic configuration 1s2 2s1. So then you need to select valency electrons. So here valency electrons, how many valency electrons? Only one valency electron. That indication only one dot. You can represent like this. Lithium only one electron. You can represent like this, otherwise you can simply represent like this. You better to write like this. Yeah. So one valency electrons means one dot. Suppose you have to take hydrogen atomic number 1. Here total only one electron. So here one important point is that hydrogen contain total how many electrons? One electron. Total how many valency electrons? One electron. So here whatever the question for hydrogen, the answer should be one only. That is the logic. Hydrogen valency 1, hydrogen atomicity, that is a different concept. Hydrogen valency 1, hydrogen atomic number 1, hydrogen valency electron 1, hydrogen valency 1, like that. Yeah. So just look at the board, dear students. Hydrogen valency electron 1, that's the reason one dot symbol. Helium 2 valency electrons, that's the reason 2 dot symbols. Boron 3 valency electrons, that's the reason 3 dot symbol. Everybody knows carbon valency electrons 4, that's the reason carbon having how many dot structures? Carbon having 4 dot structures. Just previously I have discussed about neon. So neon belongs to noble gas. Noble gas belongs to 8th A group. 8th A group indication 8 valency electrons. 8 valency electrons indication how many dots? 8. Yeah. Is it clear? This is Lewis dot structures concept. Okay, anyhow, main important point of Cousel-Lewis theory. What Cousel-Lewis theory explains? According to this theory, only valency electrons are participating in bond formation. This is important point. According to this theory, valency electrons act as Lewis dot symbols. Is it clear? Yeah. Next, we need to discuss octet configuration, my dear students. What is a octet? What is the meaning of octet? So the meaning of octet means 8 electrons. Octet means 8 electrons. Octet means 8 electrons. So what are valency electrons? Already I told you. What are octet configuration? Octet configuration means, this is very much important, octet configuration. Eight electrons present in outermost energy level. 8 electrons present in outermost energy level. 8 electrons present in outermost energy level. Don't get confused. EL is nothing but energy level. Okay? Yeah. 8 electrons present in outermost energy level. Yeah. For example, if I take neon atomic number 10. So electronic configuration 1s2, 2s2, 2p6. So total how many valency electrons here? Total how many valency electrons? 8 valency electrons. So 8 valency electrons means this one having octet configuration. This one having octet configuration. Octet configuration means stable. What octet configuration concept explains? Stability. Clear? So if outermost shell contain 8 electrons, that is nothing but stable. If outermost shell does not contain 8 electrons, that is unstable. And if outermost shell contain 2 electrons, that is duplet configuration, that is also stable, that is the exception case, whereas remaining unstable. So ultimately what I want to say is total periodic table contain 18 groups. Total periodic table contain 18 groups. Out of 18 groups, only one group is stable group, that is noble gases, that is 8th group, that is 18th group elements, whereas remaining 17 groups are unstable. Is it clear, my dear students? Yeah. So whereas remaining 17 group elements are unstable, that's the reason for stability purpose these 17 group elements are trying to attain octet configuration. They are trying to attain octet configuration. How octet configuration is gained? Very simple. By gaining electrons, or by losing electrons, or by sharing electrons, like that. Yeah. So let's discuss one important point. So let's take sodium. Sodium atomic number 11. Sodium atomic number 11. Let me ask you one important question and very simple question. Is sodium is stable or unstable? Unstable. Why? Because already I told you. Only noble gases are stable in periodic table, whereas remaining unstable. So based on numbers also we can decide this is stable or this is unstable. So just look at the board. In our chemistry, these numbers are very stable numbers. These numbers are very stable numbers. Which numbers are very stable numbers? Which numbers are very stable numbers? Noble gases. What are the noble gases atomic numbers? 2, 10, 18, 36, 54, 86. Only these numbers are stable, whereas remaining numbers are unstable. Yeah. So just look at the board. Sodium atomic number 11. So there is no 11 number. That's the reason this is unstable. For stability purpose, what sodium going to do? Is sodium going to lose electrons or is sodium going to gain electrons? That is completely depends upon atomic number. So here 11 is nearly equal to this number. 11 is nearly equal to 10 number. So if sodium wants to get stability, then what should we do? We need to remove one electron, one valency electron. So loss of one electron, loss of one electron, then it becomes like this, Na plus. So Na plus means total 10 electrons, total 10 electrons. Na means total 11 electrons. So 11 electrons means unstable, 10 electrons means stable. Yeah. So here you need to understand one important point. So first write down electronic configuration for Na plus. 1s2, 2s2, 2p6. So these are the valency electrons. Total how many valency electrons? 2 plus 6, 8. 2 plus 6, 8. That means this one having a octet configuration. Is it clear, my dear students? What is octet configuration? If valency cell contain 8 electrons, that is called octet configuration. Every atom tend to attain octet configuration by sharing electrons or by losing electrons or by gaining electrons. Is it clear? So electrons loss हो सकते, electron gain हो सकते, electron share भी हो सकते. So stability ఇక్కడ ఎలా వస్తుంది? Electron donate చేయడం వల్ల వస్తుంది, electron గెయిన్ చేయడం వల్ల వస్తుంది, లేకపోతే ఎలక్ట్రాన్ ఇంకొకరికి హెల్ప్ చేయడం వల్ల. దట్ ఇండికేషన్ షేరింగ్, మ్యూచువల్ షేరింగ్. యా ఓకే, ఎనీహౌ కమ్ బ్యాక్. సో వాట్ ఈస్ octet configuration? If valency cell contain 8 electrons, that is octet configuration. Every atom tended to attain 8 electrons in the valency cell. Yeah. So next you have to take one more example for better understanding purpose. You need to take chlorine. That is better. Chlorine atomic number 17. Is 17 is stable or unstable? Definitely unstable. Why? Because already I told you, my dear students, only these numbers are stable numbers. These numbers are stable numbers, whereas remaining numbers are unstable. So just have a small look, my dear students. Chlorine atomic number 17. 17, it is nearly equal to this number 18. So 17, 18, only one electron is the difference. What should we do? What chlorine is going to do? Chlorine is going to gain one electron. It is going to gain one electron. Why? What is the reason behind that? For stability only. Not for you, not for me. Chlorine is going to get electrons. One electron because of stability purpose. So then it becomes like this, Cl minus. Cl minus means total 18 electrons. So 18 electrons means stable or unstable? Stable. So what is the electronic configuration of Cl minus? 1s2, 2s2, 2p6, 3s2, 3p6. So total how many valency electrons? Total 8 valency electrons. 8 valency electrons means octet configuration. 8 valency electrons means octet configuration. Octet configuration means it is a stable. So Cl minus stable or unstable? Stable. Why? Because octet configuration. What about Cl? Cl stable or unstable? Cl unstable. For stability purpose only it is going to gain one electron. So ultimately here you need to notice one important point, my dear students. Atoms, sometimes atoms going to lose electrons and sometimes atoms going to gain electrons and sometimes atoms going to share electrons. Okay students, so here let me ask you one simple question. Cl and Cl minus, out of two which is more stable? Cl minus is more stable. Why Cl minus is more stable? Why? Because it contains octet configuration. Simple logic. Why? Because its outermost energy level contain octet configuration. Otherwise we can say like this. So Cl minus contain 18 electrons and Cl contain 17 electrons. So already I have given the numbers 2, 10, 18, 36, 54, 86. Only these numbers are stable numbers in chemistry. This is the very much important point. Only these numbers are stable, whereas remaining numbers are unstable. Yeah. So this is a neutral atom. This is anion. Negative charge is nothing but anion. Positive charge is nothing but cation. So always ions are more stable than atoms. And ions, in between ions, molecule is formed. Molecule. So that's the reason initially I have discussed one important point. Atoms, molecules, out of two which is more stable? Atoms, molecule, out of two which is more stable? Molecule is more stable. Yeah. So one more question. Na and Na plus. This is ion. Which ion? It is cation. What is cation? Positively charged species. This is atom. Neutral atom, out of two which is more stable? What is the stability order here? What is the stability order? This is the stability order. Na plus greater than Na. This is very, very important. Is it clear? Yeah. Suppose F minus and F, out of two which is more stable? Definitely F minus. Why? Because F minus is nothing but ion. Which ion? This is anion. What is anion? Already I told you. What is anion? Negatively charged species. Negatively charged species, that is anion. So fluorine is nothing but neutral atom. Fluorine is nothing but neutral atom. So atom ion, which is more stable? Ion is more stable. Is it clear, my dear students? Yeah. Actually in this topic mainly we need to discuss valency electrons. Already we have discussed valency electrons. Next, octet configuration. So octet configuration also completed. So next in this topic, main important types of chemical bonds. So chemical bonds mainly 4 types: ionic bond, covalent bond, coordinate covalent bond, hydrogen bond. These 4 types are very much important for any competitive examination. Any competitive examination. So first we need to discuss ionic bond. So try to understand very smooth manner. So before getting into types of bonds, little bit we need to discuss about metals, non-metals and semi-metals. Yeah. Metal. So what is metal? We'll discuss clearly. What is a metal? Metal, they form positive charge. They form positive charge. What is their nature? They form positive charge by the loss of electrons. By the loss of electrons. They form positive charge by the loss of electrons. For example, first A and second A. First A and second A, these are S block. These are S block. Total periodic table contain 4 blocks. This is also very much important point. Total periodic table contain 4 blocks. S block, P block, D block, F block. So, periodic table contains metals, semi-metals, non-metals. Semi-metal it is also called. Semi-metal it is also called metalloid, dear students. This is very important topic. Very important basic concept. Yeah. So what is the nature of metal? They form positive charge by the loss of electrons. So all S block and D block and F block contains metals only. This is important point. पूरा S ब्लॉक, पूरा D ब्लॉक, पूरा F ब्लॉक మెటల్ సే ఆతే. సో అంటే నేను ఏమంటున్నానంటే ఇప్పుడు మొత్తం S బ్లాక్, D బ్లాక్, F బ్లాక్ అన్నీ కూడా మెటల్సే ఉంటాయి అన్నమాట. వెన్ కమ్స్ టు P బ్లాక్ కంటైన్స్ 3 categories. P block contains metals, semi metals, non metals. Yeah. So but here except hydrogen. So ultimately except hydrogen, all S block, all D block, all F block metals only. And when comes to P block contains metals, non-metals and semi-metals. Okay? Yeah. So what are metals, my dear students? What is the nature of metal? They form positive charge by the loss of electrons. Next, total periodic table contain how many groups? Total periodic table contain 18 groups. Out of 18 groups, which group contain highest metallic nature? This is very much important point. Total periodic table highest metallic nature is first A group. First A group contain how many elements and what are the elements? First A group it is also called alkali metals. First A group it is also called alkali metals. Actually alkali means base. What is the meaning of alkali? Base. When you put alkali metals in water, they give basic hydroxides like LiOH, NaOH, KOH, all these are bases. That's the reason these are called alkali metals. Alkali metals when react with water, they give basic hydroxides. Yeah. So what are first A group? Lithium, sodium, potassium, rubidium, cesium, francium. But here one important point. Francium is a radioactive element. Radioactive element means it's having very less lifetime. ये जल्दी मर जाते. So no need to focus on francium. Why? Because it is a radioactive element. You have to focus on remaining elements. It is a radioactive element. It is a radioactive element. So these are main important alkali metals. So total periodic table contain 18 groups. Out of 18 groups, which group contain highest metallic nature? First A group. This group contain highest metallic nature. So here top to bottom metallic nature increases. This is the top, this is bottom. Top to bottom metallic nature increases. Top to bottom metallic nature increases. That indication out of all, which one contain highest metallic nature? Cesium contain highest metallic nature. Cesium contains highest metallic nature. Most electropositive element. Electropositive element. most electropositive element. Highest metallic nature is nothing but highest electropositive only, don't get confused. Metallic nature directly proportional to electropositive nature. Non-metallic nature directly proportional to electronegative nature, just reverse, don't get confused. Yeah. Okay dear students, first A group contain highest metallic nature. Next, what about highest non-metallic nature? Highest non-metallic nature, non-metals. So what is the nature of non-metal? What is the nature of non-metal? They form negative charge. They form negative charge by the gain of electrons. By the gain of electrons. They form negative charge by the gain of electrons. Just opposite. Metal को non-metal opposite होते. Yeah. So what are the examples of non-metals? Only P block contains. Only P block contains. Only P block contains. Only P block contains non-metals. So which group contain highest non-metallic nature in periodic table? 7th A group. This is called halogen family. This is called halogens. Halo means salt, gen means producing, salt producing elements. Yeah, what are the elements? What are halogens? Full color, bright in atom. This is the technique. By using this technique, you can simply remember these elements. Full color, bright in atom. So these are halogens. Out of all, which is more electronegative element? This is the top, this is bottom. Top to bottom, non-metallic nature decreases. Top to bottom, non-metallic nature decreases. Top to bottom, non-metallic nature decreases. That indication bottom to top, non-metallic nature increases. So that's the reason which one contain highest non-metallic nature? Fluorine. Highest non-metallic nature means most electronegative element. Most electronegative element. So in periodic table, which element contain highest electronegative nature? Fluorine. In periodic table, which element is the highest non-metallic nature element? Fluorine. So I have given two formulas, dear students. First formula, metallic nature directly proportional to electropositive nature. Electropositive nature. Next, non-metallic nature. Non-metallic nature directly proportional to electronegative nature. Electronegative nature. These two formulas very much important, my dear students. These two formulas very much important. Keep your mind. Yeah. Let me ask you one important question. Total periodic table contain how many elements? Total periodic table contain how many elements? Total periodic table contain 118 elements. 118 elements. Out of all elements, which element contain highest metallic nature? Highest metallic nature is cesium. Which element contain highest non-metallic nature? Highest non-metallic nature element is fluorine. This is very much important point. This is highest electronegative element and this is highest electropositive element. Is it clear, my dear students? Okay students, once again recap the topic. Today what we have discussed. Yeah, just look at the board. First, today topic is chemical bonding. So in this topic, main important valency electrons. So what are valency electrons? The number of electrons present in outermost energy level. The number of electrons present in outermost energy level are called valency electrons. Yeah. So let's take lithium. Lithium having one valency electron. Lithium having one valency electron. Next, let's take beryllium. Beryllium having two valency electrons, and this is the diagram for valency electrons. Yeah, this is first energy level, this is second energy level, this is third energy level, this is fourth energy level. So out of four, which is ending energy level. This is ending energy level. So the number of electrons present in ending energy level. Ending energy level is nothing but outermost energy level. Outermost energy level electrons are called valency electrons. Only valency electrons are participating in bond formation. Valency electrons are active electrons. This is very much important point. Next, let's have a small look on periodic table. Let's have a small look. This is the periodic table. So here you need to understand one important point. Total periodic table contain how many periods? Total periodic table contain 7 periods. Total periodic table contains 7 periods, and the total periodic table contain how many groups? 18 groups. Yeah. So generally group represented a vertical column like this. So and period represented a horizontal line like this. So just look at the board. These are periods and these are groups. Okay students, here you need to understand this point. This point is a very much important point. Valency electrons act as group number. If valency electron is 1, group number is 1. If valency electrons is 2, group number 2. If valency electrons are 7, group number 7. Like that. Next, Cossel-Lewis theory. This is the basic introduction theory for electrovalency. This is also called electrovalency theory. Yeah, this theory was discovered Cossel and Lewis. That's the reason this is called Cossel-Lewis theory. So according to this theory, what this theory explains? This theory explains valency electrons. So valency, according to this theory, valency electrons are participating in bond formation. The number of electrons present in outermost energy level are called valency electrons. So next to valency electrons act as Lewis dot symbols. Valency electrons act as Lewis dot symbols. So if valency electrons 2, how many dots are possible? 2 dots. If valency electron only one dot is possible. Just have a look. Hydrogen having only one valency electron. That's the reason 1 dot. So lithium 1 dot. So group number 1 means total valency electrons 1. Group number 2 means total valency electrons 2. Total valency electrons 2 means total dots 2. Like that. Next, Lewis dot structures already we have discussed. Next, octet configuration. This is very much important. So what is octet? Octet means 8 electrons. What is octet configuration? If valency cell contain 8 electrons, valency cell contain 8 electrons. So 8 electrons present in outermost energy level. 8 electrons present in outermost energy level are called valency electrons. In our chemistry, only these numbers are stable numbers. 2, 10, 18, 36, 54, 86. Whereas remaining numbers are unstable. Yeah, just look at the board. Let's take neon. Neon atomic number is at 10. So electronic configuration is 1s2, 2s2, 2p6. So here, this is the first energy level. This is the second energy level. This is also called second energy level. So here, second energy level is the outermost energy level. So outermost energy level contain 2 plus 6. 2 plus 6, total 8 electrons. 8 electrons means octet. Octet means stable. Next, let's take sodium. Sodium 11 electrons. 11 electrons means stable or unstable? Unstable. Just we have discussed at this point, only these numbers are stable, whereas remaining numbers are unstable. So for stability purpose, it is going to lose 1 electron. So loss of electrons means sodium is metal or non-metal? Sodium is metal. Why? Because what is the nature of metal? Metal, they form positive charge by the loss of electrons. Yeah. So Na plus. Na plus means ion. Next. Same. Chlorine. Chlorine atomic number 17. So 17. For stability purpose, it is going to gain electron. Going to gain electron. That indication chlorine is non-metal. What is the nature of non-metal? They form negative charge by the gain of electron. Yeah. Next. Next video, we will discuss ionic bond, types of bond. Okay students, listen very properly. This is very useful to you. Bye for now. See you again.
పబ్లికేషన్స్ వారి పుస్తకాలను ఇప్పుడు మీరు ఆన్లైన్లో కూడా ఆర్డర్ చేయొచ్చు. యూ కెన్ జస్ట్ లాగ్ ఆన్ టు www.sonlinebooks.com. ఈ వెబ్సైట్లోకి మీరు లాగిన్ అయ్యి మీకు కావాల్సిన పుస్తకాన్ని ఆన్లైన్ ఆర్డర్ చేయొచ్చు అండ్ మీ డోర్ స్టెప్ దగ్గరికి డెలివరీ కూడా చేయడం జరుగుతుంది.